All right, guys, another virtual day. We are not going to slow down though. We are starting some new stuff today, and I wanted to record this so you can kind of take your time, go whatever pace you need to do today. But we are solving one-step inequalities. This is kind of just going to be an intro day for us. We have seen this before. It is just like solving equations. The only difference is all of our problems are going to have these inequality signs. Okay. These notes are posted. You can print them or just do your notes in your copybook, up to you. But I'm going to get started, follow along, and there is a homework assignment at the end of the note packet, so make sure you also do those 8 problems. Okay, so again, we are doing just one-step inequalities, and anytime you have an inequality, that means you're going to have one of those symbols, less than, greater than, less than or equal to, greater than or equal to. Okay, so my first one, the sum of x and 3 is less than 8. So first thing we are doing here is translating that sentence into an algebraic inequality. So the sum, remember, is addition. So I have x plus 3 is less than 8. And we want to solve these just like equations. So my one step is to subtract 3 from both sides, which means x is less than 5. And what that looks like in what we call set builder notation is I'm going to do a little squiggly bracket, and I say x, and then I do a straight line, which means such that, and I say x is less than 5, and then another squiggly bracket. On my number line, you have to put some numbers on there for you. The important number to see is 5, since that's where we're going to be marking. And because I am less than, I know equal to, remember we're going to do an open circle. I'm going to do it on 5. And these are the problems where we draw a line in the direction where all the values satisfy it. So to the left, all those numbers are less than 5. So I draw a line that goes to the left. Because any of those numbers over to the left, I could plug in and say it is less than 5. So 2 is less than 5. 3 is less than 5. I could do negative 752, and that's less than 5. Okay. My second one, 5 subtracted from m is more than negative 11. Again, we're going to translate it first. 5 subtracted from m. So that means m goes first. You take 5 away, and we're saying that value is more than negative 11. One step to solve, add 5. M is greater than negative 6. Our notation, we can do m such that m is greater than negative 6. Whoops, I need a curly, there we go, curly bracket. And then again, your number line, you fill it in. Higher numbers to the right, lower numbers to the left. Again, we're going to do an open circle, and it's going to be at negative 6. And I'm looking for all the values that are greater than negative 6, which means it's all the numbers to the right. So I'm going to do my line and arrow to the right. Fourth one down, less than or equal to. This is where we start having solid circles. If that line is underneath it, you're going to fill in your bubble on your number line. So we have the difference of b and 1/2 is at most 3/4. You know I had to throw in some fractions here. So difference implies subtraction. So b minus 1/2 is at most, which means that value is all going to be less than or equal to 3/4. We're going to add a half to solve. A little fraction practice for you. If we're doing 3/4 plus 1/2, remember we need a common denominator, so 3/4, and we can do plus 2/4. Add straight across the numerators. Your denominator stays the same. So my final answer for this one is going to be b is less than or equal to 5/4. And when it comes to graphing on your number line here, count by fourths if you want to. 1/4, 2/4, 3, 4, There's no rule that you always have to count by whole numbers, okay? So then we're going to have a solid circle at 5/4, and I need all the numbers that are going to be less than that. Less than is to the left. And my last example here, 10 added by n is greater than or equal to 12. 10 added by n is greater than or equal to, puts the line underneath, 12. Solving just like an equation, subtract 10 from both sides. N is going to be greater than or equal to 2. Label your number line with whatever numbers you want, as long as 2 is on there and you're counting by consistent values. Okay. I need a solid circle at 2, and my arrow is going to go right because that's the direction all the numbers are bigger than 2. I'm going to do a couple more examples of these. I want to focus on just the one-step equation, so I'm going to just do the problems on the left side of this page. So try them first yourself, pause the video, try them, then come back, check them, see how you did. Try to write the sentence as an inequality, solve it, put it in set builder notation, and try to graph it. Okay. So again, I'm focusing just on the 2 problems on the left. The sum of a number x and 17 is no less than 26. So if you set up your inequality as x plus 17 is greater than or equal to 26, nice work. Your one step to solve should be subtracting 17, which means you would have gotten x is greater than or equal to 9. Your set builder notation in your curly brackets looks just like this. X such that x is greater than or equal to 9. I plotted 7, 8, 9, 10, and 11 on my number line. I have a solid circle at 9, and all the values that are bigger than 9 are to the right. So check how you did. Did you write your inequality correctly? Did you do the one step to solve and get x is greater than or equal to 9? Did you do the set builder notation? All right. Do you have a solid circle at 9? And the last one I want you to try is down here on the left. 12 is at least a number x decreased by 7. So 12, then here's my keyword, at least, so greater than or equal to x decreased by 7. So I have to subtract. So check your setup first. Then I'm going to add 7 to both sides, and I have 19 is greater than or equal to x. If you don't like that x is on the right side, the flipped version of this would be x minus 7 is less than or equal to 12. And then when you solve it and add your 7, you have x is less than or equal to 19. These two answers are the same thing, but check your inequality direction. Okay. Your set builder notation in your curly brackets, you could have either of those inequalities written. I like having x go first, so I'm going to do x is less than or equal to 19. It also, when x goes first, kind of tells me the direction my arrow is going to go on my number line. So I'm going to do it like this, a solid circle at 19, and an arrow going left. The inequality only tells you which way to go on your number line if your x value is on the left of it. Okay, notice how it's the opposite of this one because x is on the right. So I like to have it flipped around so x is on the left. Okay. So if you scroll through the document I posted, this is the page you're looking at as for like homework or your practice problems, and you're doing 1 through 8. You're solving and graphing. So I've given you the inequality and the number lines. You don't have to do set builder notation, but try these 8. We will check them together in class. And reach out if you have any questions. But again, these are all just one-step inequalities, solving just like equations. All right, good luck. Enjoy the rest of your virtual day.